The information in this video is based on the most current information available at the time of production. While affordable safety training works hard to make sure these materials are current, the employer has sole responsibility for compliance with all laws, regulations, and standards. This video is sold with the understanding that AST is not providing professional or legal advice. Employers should have a reliable source for current regulatory information and best practices.
Hello, my name is Jeremy Norton, and I will be guiding you through this Hydrogen Sulfide Awareness course. As a nuclear engineer and chief machinery operator in the U.S. Navy, I was responsible for power production and propulsion on the USS Carl Vinson. Now, the machinery and equipment necessary for this passed through many small spaces. And since we had 5,000 sailors on board the ship, there was a significant amount of sewage. This passed through what we called CHT piping, which was in nearly every space I entered. So hydrogen sulfide was a risk that we had to be aware of on a daily basis. And hydrogen sulfide training was something that I had to deliver to my team frequently. So today, that is what I'm going to do with you. This course will provide awareness level training of hydrogen sulfide hazards. We will learn what hydrogen sulfide is, the hazards of hydrogen sulfide, how to identify potentially hazardous areas, and how to avoid areas with potential hydrogen sulfide risk. By the end of this course, you will be able to recognize hydrogen sulfide hazards early before they put you or your employees at risk. Hydrogen sulfide is a naturally occurring gas formed when organic materials breaks down in the absence of oxygen. This process commonly occurs in industrial, municipal, and natural environments. Hydrogen sulfide may be encountered in locations such as sewers, wastewater treatment facilities, storage tanks, pits, sumps, and oil and gas operations. Because these environments are common in many industries, workers may be exposed during routine or non-routine tasks. Understanding what hydrogen sulfide is and where it may be found is the first step in recognizing potential hazards. Hydrogen sulfide can be produced when organic material breaks down in the absence of oxygen. So if there is organic material and limited oxygen, there is likely a hydrogen sulfide hazard. One of the most important things to understand is that hydrogen sulfide can be dangerous at low concentrations. Workers often underestimate the hazard because it is invisible, and at low concentrations, it has the smell of rotten eggs. So not being able to smell that smell often gives people the false sense of security that there is no hydrogen sulfide hazard. When in actuality, as the concentration levels go up, it overcomes the senses and you can't smell it. Awareness means recognizing where the hazard might be present, even if you can't see it or smell it. Hydrogen sulfide does not behave like a typical airborne hazard. Once released, it moves quietly and settles into the work environment in ways that make it especially difficult to recognize and control. A key reason for this behavior comes from basic chemistry. Sulfur sits much lower on the periodic table than the primary components of air, such as nitrogen and oxygen. Elements lower on the table have a higher atomic mass, which means compounds that contain them are naturally heavier. Because of the molecular weight, hydrogen sulfide does not simply disperse upward. Instead, it migrates along floors, collects in depressions, and becomes trapped in spaces with poor natural ventilation. This makes areas such as sumps, vaults, trenches, pits, and confined spaces particularly dangerous, even when the surrounding work area appears to be normal. A space that was safe minutes earlier can become hazardous without any visible change in conditions, especially when work activities disturb deposits, open process equipment, or change airflow patterns. In addition to its toxicity, hydrogen sulfide is highly flammable and explosive under the right conditions. When mixed with air, hydrogen sulfide becomes flammable at concentrations of approximately 4.0 to 4.3% by volume. The gas remains explosive up to approximately 44 to 46% by volume, known as the upper explosive limit. Within this range, even a small ignition source, such as a spark, hot surface, static discharge, or open flame, can trigger a fire or explosion. In confined or poorly ventilated spaces, Hydrogen sulfide can rapidly enter this explosive range if a large release occurs. This is why continuous gas monitoring, ventilation control, and strict work procedures are essential whenever hydrogen sulfide may be present. Hydrogen sulfide primarily affects the body through inhalation, and even short-term exposures can cause serious health effects. The effects depend on how much hydrogen sulfide is inhaled and for how long. At extremely low concentrations, around 0.01 to 1.5 parts per million, many people can detect a rotten egg odor. However, the ability to smell hydrogen sulfide cannot be relied upon for safety because at higher concentrations, the sense of smell is quickly lost. At 20 to 30 parts per million, workers may begin to experience fatigue, loss of appetite, headache, irritability, poor memory, and dizziness. Around this level, the odor has been reported to change to a sweet smell. At 50 to 100 parts per million, mild eye and throat irritation can occur with exposures of about 1 hour. At 100 parts per million, hydrogen sulfide reaches the level considered immediately dangerous to life and health. At this concentration and above, a worker's ability to escape may be impaired, and serious or irreversible health effects may occur without proper protection. At 100 parts per million, more serious acute symptoms develop within minutes to hours. Coughing and eye irritation and loss of sense of smell within 2 to 15 minutes. Altered breathing and drowsiness within 15 to 30 minutes. Throat irritation within 1 hour. With continued exposure, symptoms worsen and death may occur within 48 hours. At 200 to 300 parts per million, exposures of about 1 hour can cause marked eye inflammation and respiratory tract irritation. And with prolonged exposure, fluid buildup in the lungs may develop. At 500 to 700 parts per million, severe effects occur quickly. Staggering and unconsciousness within about 5 minutes. Serious eye damage within approximately 30 minutes, and death within 30 to 60 minutes if exposure continues. At 700 to 1,000 parts per million, hydrogen sulfide can cause rapid unconsciousness or collapse within just 1 or 2 breaths. Breathing ceases and death can occur within minutes. At concentrations above 1,000 parts per million, death is often nearly instantaneous. In addition to the immediate dangers, repeated or prolonged exposure to hydrogen sulfide can result in long-term health problems, including chronic respiratory irritation and reduced lung function, persistent headaches, fatigue, poor memory, irritability, and difficulty concentrating, increased sensitivity to respiratory infections, and potential cardiovascular strain. This is why hydrogen sulfide is considered one of the most dangerous industrial gases and why strict work procedures, continuous gas monitoring, proper ventilation, and respiratory protection are critical wherever hydrogen sulfide may be present. Hydrogen sulfide affects the body quickly and can be fatal at high concentrations. At elevated levels, workers may collapse without warning. The reason that the gas is so deadly is its chemical makeup. The molecule of hydrogen sulfide is made up of 2 hydrogen atoms and 1 sulfur atom. The sulfur atom has a negative charge of -2, and the hydrogen atom has a positive charge of +1. This yields a stable molecule with no charge. Since the molecule has no charge, it passes easily through the lungs and into the body. When it enters your body, the hydrogen gets stripped away, leaving a very dangerous, negatively charged intruder in your body. This allows it to very quickly bond with your cells and replace oxygen. This is exactly how cyanide works. Many fatal accidents involve people who did not have time to get clear of the hazard or somebody who attempted an unplanned rescue. That is why it is so important for us to train on this hazard so that we don't commit the same error. Because of the serious health risks associated with hydrogen sulfide, regulatory and advisory organizations have established exposure limits to protect workers. The Occupational Safety and Health Administration, or OSHA, enforces permissible exposure limits for hydrogen sulfide in the workplace. Other organizations, such as the National Institute of Occupational Safety and Health and the American Council of Governmental Industrial Hygienists, provide additional guidance and recommended exposure limits based on current research. These limits are designed to reduce the risk of injury, illness, and fatal exposure. There are limits for both extended exposure and peak exposure. OSHA sets a permissible exposure limit for hydrogen sulfide of 20 parts per million, with a short allowance of 50 parts per million for up to 10 minutes under specific conditions. The American Conference of Governmental Industrial Hygienists, or ACGIH, recommends even more conservative limits. ACGIH establishes a time-weighted average of 1 part per million and a short-term exposure limit of 5 parts per million. The key takeaway is not the exact numbers, but the fact that harmful effects can occur at very low concentrations and that safe exposure margins are narrow. If hydrogen sulfide may be present, your employer is responsible for evaluating the hazard and implementing controls. Your responsibility is to recognize warning signs and stay out of unprotected hazard areas. Now, right now, we are not expecting you to memorize permissible exposure levels. What I want to emphasize is that the levels are low and they can be quickly exceeded. Now, you may be asking yourself, why is the limit set by the American Council of Governmental Industrial Hygienists so much lower than the OSHA PEL? And that's an excellent question. I mean, it's 20 times lower than the OSHA PEL. The OSHA permissible exposure limit for hydrogen sulfide was set at the founding of OSHA in 1971 and has not been changed since. And even then, it was built on science from the 1950s. The ACGIH updates their recommendations as the science changes. As you can see, the health hazard from hydrogen sulfide is much higher than we initially anticipated. If hydrogen sulfide may be present, your employer must evaluate the hazard and provide mitigation steps. Your responsibility is to understand the hazard, recognize warning signs, and stay out of hazard areas. Hydrogen sulfide is a hider. It seeks out enclosed, low-lying, and poorly ventilated spaces. Because hydrogen sulfide is heavier than air, it sinks to the lowest point, filling spaces from the bottom up like invisible water. Here are the high-risk locations you need to recognize. In sewers, organic waste breaks down in the dark without oxygen. This creates pockets of gas that settle at the bottom of manholes and in stagnant sections. When you pop open a manhole cover, the change in pressure can lift that gas directly into your breathing zone. Furthermore, disturbing the sludge at the bottom by jetting a line or stepping into it can release massive amounts of gas instantly. Any storage tank or pit holding wastewater, sludge, or oil acts as a generator. The gas is often trapped inside the sludge. It may be stable while sitting still, but if you stir it up by gauging the tank, cleaning it, or starting a mixer, it releases gas rapidly, just like shaking a soda can. You don't need to be in a sewer to find sewer gas. In open trenches, hydrogen sulfide can migrate through the soil from nearby leaking pipes or rotting organic material. Because the gas is heavy, it pools on the floor of the trench, exactly where you are bending down to work. Underground utilities can be an overlooked hazard. Valve boxes, meter pits, and electrical vaults are not designed to carry sewage, so workers often assume that they are safe. Gas can migrate into these vaults from soil cracks or from stagnant rainwater and rotting leaves. Never assume a vault is safe just because it is a clean water utility. In refineries and processing plants, hydrogen sulfide is naturally present in the crude oil and process streams. It lingers around pumps, flanges, and drain valves. Be especially careful during maintenance tasks like sampling and gauging. A leak here isn't just a puddle, it's a toxic cloud that hangs low near the ground. Finally, a critical rule regarding signage. While regulated industrial sites will mark specific hydrogen sulfide zones, public streets and construction sites often have no warning signs at all. Do not rely on signs to keep you safe. If a space is enclosed, low-lying, and unventilated, treat it as a hazard until you have tested the atmosphere. Most hydrogen sulfide incidents occur in predictable locations. Low-lying, enclosed, or poorly vented areas should always be of concern. If it could have organic materials and a lack of oxygen, you should ask the question. Has this space been evaluated? Do I have monitoring equipment? Am I allowed to enter? If the answer to those questions are not abundantly clear, you should not enter. There is another hazard area that I would like to emphasize. If you are working near a waste treatment plant or an oil refinery or something similar, hydrogen sulfide can gather in low-lying areas. These are commonly referred to as stink damps, and they can be deadly. Now, these areas should be posted with hydrogen sulfide warning signs, but sometimes the wind can push hydrogen sulfide clouds into surrounding areas. Hydrogen sulfide is commonly monitored using fixed gas detection systems or personal gas monitors. These devices are designed to alert workers when hydrogen sulfide concentrations reach unsafe levels. Gas monitors use audible alarms, visual indicators, and vibration alerts to ensure workers are notified even in noisy environments. Alarm set points are typically established at multiple levels to indicate increasing risk. When an alarm activates, it means hydrogen sulfide has reached a concentration that requires immediate action. When a hydrogen sulfide alarm sounds, your response must be immediate and deliberate. Do not investigate the alarm or attempt to solve the problem. If the alarm sounds, stop work immediately. Move away from the area, follow your company's evacuation plan, and alert a supervisor. Never assume an alarm is false or attempt to override it. Gas monitors are life-saving devices, and ignoring them can have fatal consequences. Hydrogen sulfide awareness saves lives by preventing exposures before they happen. Here are the key points to remember. Hydrogen sulfide is produced when organic material decomposes in low oxygen environments. It is invisible. It is heavier than air and accumulates in low areas. It can incapacitate without warning. You must immediately evacuate if a hydrogen sulfide alarm sounds or there is an indication of dangerously high concentrations of it. One of the most concerning things about hydrogen sulfide is it can form in places you don't expect. So knowledge and understanding of the hazards is the best means of protection. If you ever find yourself wondering if hydrogen sulfide could be a hazard, stop and ask a supervisor.